Okay, guys, welcome back. Welcome back. And let's get started. Today, we're going to talk about fractions. Today, we will talk about fractions. Okay, we'll talk about fractions. So, what is a fraction anyway? So, we can say the fraction is a piece of a whole. It's a piece of a whole. We can say the fraction is a numerical quantity that is not a whole number. So let's put it this way. It is a numerical quantity that is not a whole number. That's a fraction. I want to say a fraction is a numerical quantity that is not a whole number. And a fraction, let me give you an example of a fraction. An example of a fraction is something like 2 3/4, for example. That's a fraction. So the whole is 4, and the 3 is the parts. So you don't take the whole 4, you take 3 equal parts of 4. So this is a fraction. Let's say we get the top number here. The top number here is called the numerator. We get the bottom number here is the denominator. And the bar in the middle here is called the fraction bar. This is like, the fraction bar is like division. This is the same as when you divide this, or when you basically this is the same as division. So the bar, the fraction bar, is the same as division. This division sign. So here we get a fraction bar. Okay. And let's say if you get a whole pizza, for example, that's a whole pizza, right? And you take this pizza, you cut it in 2 halves. You cut that pizza in 2 halves, 2 equal halves, by the way. Okay, kind of. So let's say that you call this one the colored part. This is the half you have colored. So now what I need to tell you, this is how you represent the half of the pizza you've taken from the whole pizza itself. So the whole pizza, this is 1/2 and 1/2, that's 2 halves. So you might want, the fraction for this one is the part that is colored, okay, which is 1, and plus the total altogether. This is 1 part and 2 part. This is 1/2. That's the fraction for 1/2. Okay. So where do you think they use fractions? Use of fractions. Where do we use them? We use them in weight, taking weight of something, some example. Where do we see them? We see them used in recipe. Okay, and that's why we get them. So why do you think? Why are they used? Why are they used? Let's say, why are fractions used? Okay, they are used when it comes to leftover. leftover, or something that is not a whole. That is not a whole. And this is how we use fractions, okay? And you might want to take let me give you an example, because we're going to do some fractions here. You might want to take a pie. Let's say if you get a pie, you try to divide this in 3 equal parts. That's another one. These are not 3 equal parts. So let me make sure I make this a little. Let me do a much better job here. Okay, so we want to divide this pie in 3 equal parts. Okay, and let's say we colored 2 parts of the 3, and remember, we colored 2 of the 3, so we're talking about fractions. So if I need to write a fraction for this one, I'm going to put the fraction bar and plus the total bars here, the total parts. This is 1 part, this is 2 parts, and 3 parts, and I'm going to put the 3 here. We get 3 parts. So once I get these 3 parts, so I want you to give me a fraction for the colored parts, okay? And this means how many parts are colored. This is 1 and 2, and this one is not colored. So you've colored 2 parts out of 3 total, okay? And you can use a circle to do that, as you can represent the same fraction by using a rectangle to do that. So this rectangle, it can be divided in 3 equal parts, and you have colored 2 parts of that rectangle, and I want you to give a fraction of the colored spot when it with respect to all the parts. So still we get 1, 2, and 3 total divided by 3, which is over 3, but at the same time the colored parts are 1 and 2. So these are the parts that are colored, and you put the 2 on top in the numerator and the 3 at the bottom, which is the total. That's why we say fractions are parts of a whole. So the whole is at the bottom here and the parts are on top. So let me write it for you. So what are fractions? Fractions are parts of wholes, okay? And here we get whole. So it's like a pizza. You get a pizza here, you cut that pizza, that's the whole pizza, in 3 parts. So the 3 parts is at the bottom here. And if you give 2 pieces to your friends or to someone, so in other words, whatever you have left that's what we said. We use fractions for leftovers and other things. Okay? And now we want to go and start to do some operations on fractions. Okay? Operations. So we're going to add, subtract, multiply, and divide fractions. All right? We're going to add, subtract, divide, multiply fractions. Okay, so let me write this here for you. Let's go. We're going to do operations on fractions. All right, we're going to do operations on fractions. As we are doing those operations on fractions, we're going to start with some fractions here. As you can see, let's say we get this fraction, which is we take another color. We get this one, which is 1 over 3 plus 1 over 5. Let me not take this for now. 1 over 3. We're gonna do, because I'm trying to do, plus 1 over, let's say 2 over 3. In this case here, we're doing fractions. We're adding fractions with the same denominator, okay? So let me write this down here. Same denominator. All right, same denominator. That's it. We get the same 3 here, and we get this the 3 over here. So what you do for this one, when you're adding fractions with the same denominators, so what you do, you keep the denominator, which is the same thing, that's 3. You keep the 3, not 3 plus 3 is 6. No, you just keep the 3 and you add the numerators, okay? So when adding fractions with the same denominators, what you do, you keep the same denominator and you add the numerators. So I'm going to keep the same denominator and I'm going to add the numerators, which is 1 plus 2. That's 3 over 3. That's 3 over 3. But when we divide 3 over 3, if you get a pizza, you know, and you give 3 pieces to your friends, and that's the total. So basically, you get nothing left. So you have used the whole pizza, which is this is equal to 1. Okay, 3 over 3 is equal to 1. So that's when you're adding fractions with the same denominator. Adding fractions with the same denominator. Okay, what you do, you keep the denominator and you add the numerator. So what do you do here? Keep numerators. Not numerator. When adding fraction with the same denominator, you keep the denominator and you add the numerators. Okay, this is adding fraction with the same denominator. Let's see if I can give you another one. Let's go and do another one. What we're going to do here is going to be, let's say 5. Let's say 2/3 plus, let me eliminate the 3 here now. We used it already. We're going to use another one. Let's say 2/5 plus 7 plus 3/5. Okay, that's the same denominator again. So what do we do? As I told you earlier, we keep the same denominator. So what you do, you keep the same 5, okay, and then you add the numerators. So this is 2 plus 3 is equal to 5. And 2 plus 3. So this is equal to 5 over 5. Look at it. This is equal to 1. Okay, that's equal to 1. So 5 over 5 is equal to 1. So that's your answer. That's one here. Okay. So now let's go and do and add fractions with different denominators. So we call this same denominators, same, which is same is the same as like denominators. Okay, we're gonna add fractions with different denominators or unlike denominators. So that's what we're gonna do next. All right. Okay, so adding fractions with unlike denominators. When I say unlike, I want to say different. So this means the denominators are not the same. They're not the same. So let's go and do this right now. So let's say if I get 2/5 plus 3/7, Okay, you see 5 and 7 are different. We cannot do it the same way we did it earlier. Okay, we cannot do it the same way we did earlier, but we're going to use a different technique to do that. So some people do a cross multiplication, but I want to I don't like it the way they tend to do it, but I want to give you some real uh, you know I want to teach this to you in a very scholastic, in a way that if you can use it and teach it to anyone else, basically. So what you're gonna do? So when you get fractions with a different denominator, you look for something called the common denominator. Okay, and this is a common denominator here. You're gonna write this here, common denominator. So what you do here, and we get 5 and 7. These numbers, they call them prime numbers. So there is no way to decompose those numbers to do anything different. We just multiply this number by that number here to get the common denominator. Okay, so what we do, we need to get that common denominator here at the bottom, and this is the common. Let me go back here. This is for 2/3 plus we're going to get the same denominator for 3/7. Okay, so let's say the common denominator for these two is 5 times 7. That's 35. But 35, so, and 5 times 7 for the second one, for the 3/7 is 35 as well. Okay, you see, we're trying to take this back to the example we did earlier with the same denominator. So when you get different denominator, you need to bring your fraction to the same denominator. You see where I'm going with this? But if you multiply 5 by 7 to get 35, what you're going to tell yourself, you're going to say, what did I multiply this 5 by to get 35 over here for this fraction? For this fraction here. And you get that 35 over here. You're going to say, what did I multiply this 5 by to get 35 over here? And you might, I can tell you that you multiply this by 7. You see, it's like you kind of change those numbers when it comes to get to this common denominator you're having here. So you multiply this by 7. So if you multiply 5 by 7 to get 35 over here, you want to balance your fraction. Whatever you multiply this 5 by, you should do the same for the 2 on top. So you multiply 5 by 7, so you should multiply 2 by 5. If you multiply 5 by 7, you should do the same as this one. So this is the 2 we got here. This is the 2. So 2 7, it was 2 the 5th, but we multiply this one by 7. You see, because you multiplied this 5 by 7 to get 35, you're going to multiply the same 2 by 7 up here. So now you have balanced this fraction here. So now let's go over here. We get 35. We multiply 7 by what number? So you're going to tell yourself, what did I multiply 7 by to get 35 over here? So you multiply by 5, right? So if you multiply the bottom, which is the denominator, by 5, so you should do the same on top for that one. You should do the same on top for that one. So you multiply this 3 by 5. You see what you do? You kind of change the fact, the number. You're going to multiply the numerators by, okay? So you take the 7 that is here, you put it here for this one, and you take the 5 that is in the first one, you put it for the second one. So now we're getting on the right track. So the common denominator is 35 for both of them. So this is equal to, and we're gonna get 35, but 7 times 2 is 14, plus 35, 5 times 3 is 15. All right. So now we take our fraction back to the previous example. We put everything over the same 35, and we add 14 and 15. 14 plus 15 is equal to 29. So 29 over 35. And this is your answer. The reason I'm saying this is your answer is because 29 over 35 is the answer, because 29 and 35 cannot be decomposed so that you can simplify. So 29 itself is a prime number. And if this concept is new to you, you may let me know in the comment so that I can do some review with you guys on prime numbers. So 29 is a prime number, and there is no way we can simplify this answer. So the answer is the way it is, which is 29 over 35. This is the answer for this fraction. 2/5 plus 3/7 is equal to 29 over 35. All right. And let's go and do another example. Let's go to another example. All right. Let's go to another example. Let's say we get 11 over 13 plus 1 over 2. Once again, we get two different denominators here, 13 and 2. They're not the same, and 13 is a prime number. So what we have to do, we just multiply 13 by 2 to get the common denominator here. So 13 by 2 is equal to 26. This is the common denominator. So 13 by 2. Because 13 is a prime number, 2 is a prime number as well. So there is no way we can find a common factor for both of them. So you just multiply them. So what you got here, this is the common denominator here. We call this common denominator. Okay, and since this is common, so we're going to tell yourself, what did I do with this 13 here? What did we multiply 13 by to get 26? So you just, since you get two fractions here, you say, I multiply by 2. Because pay attention to this 2. Whatever you do with this one, and you do the same on top. So if you multiply this by 2 to get 26, you should multiply 11 by 2 as well on top. So I'm going to say this is 11 times 2. That's what I did for the first fraction here. So plus, this is the plus sign I got here, plus. So what did you do with this 2 here to get 26 over here? Oh, you multiply by 13. Okay, by 13. So whatever you do with the 2, you do the same with the 1. So you get 13 times 1. Okay, and you get, this is 11 times 2. That's 22, plus 13 times 1, that's 13. So 22 plus 13 This is equal to, let's say, over 26. And 22 divided by plus 13 is equal to 35, right? 35. So the answer is 35 over 26. The answer is 35 over 26. And I want you to ponder on this one here. 35 over 26 is called an improper fraction. This is called an improper fraction. Okay. It all depends on how your teacher or you want to get the answer. But 35 over 26 is called an improper fraction. And since we have an improper fraction, this takes us to another concept that I'm about to teach you right now. We're going to go over so that you can transform an improper fraction to a mixed number. An improper fraction to a mixed number. So what is an improper fraction? An improper fraction is a fraction where the denominator is more than the numerator, I should say, is more than the denominator. An improper fraction is a fraction where the numerator is more than the denominator. All right. So when the numerator is more than the denominator, because in a good case, usually fractions, the numerator should be less than the denominator, okay? The numerator should be less than the denominator. So whenever you get a fraction like this, where the numerator is more than the denominator, you should convert that so that the numerator is less than the denominator. So this takes us to our next lesson on fraction called mixed numbers. Let's go and work with the mixed numbers. Mixed numbers. So what is a mixed number? A mixed number is a type is a fraction that is converted. That's the conversion of an improper fraction. I should say that. So we're going to talk about mixed number. Mixed numbers, okay? So you only use mixed numbers when you get improper fractions. So remember, the improper fraction we had earlier was 35 over 26. Okay, that was the improper fraction we had. 35 over 26. So whenever you get such a fraction, we need to convert that fraction to a mixed number. A mixed number, the format of a mixed number goes like this. If it's for example, it's going to be, if A is the number, we're going to get A and B over C. So that's how it's going to go. So basically we're going to convert this improper fraction to a mixed number. Okay? How do we do this? We use what is called the long division. The long division. So this is that's how we're gonna convert this to a mixed number. We're gonna use what is called the long division. So let's do that right now. Let's do that long division. This is 35 over 26. I'm gonna put 26 here, and we get 35. over 26, 35. And this is how we do it, guys. And I'm going to write it here. So I'm going to give you some time to breathe when we get to that one here. We're going to make sure that we convert this fraction to a mixed number. And the only way to do this is to use the long division. This is the long division here. So now, how many 26 do we have in 135? In a 35? That's 1. Okay, that's 1. So how many 26 do we have in a 35? So 1. So this one we got here, you're going to multiply this by the 26. This is multiplication. So 1 times 26 is 26, and you take the 26, you put it right here. And once you put it right here, you subtract. Remember when you do this in grade school, so you subtract over here. That's what we're going to do. And once you subtract this one here, and you're going to make sure that you're going to borrow 1 from this 3 here. And once you borrow 1 from it, this becomes, remember guys, when I told you to borrow, you're going to go borrow 1. Okay. We're going to borrow 1 from this one here. So it's no longer 3, now it's 2. And the 1 you borrow becomes, you got it here. That's 10, because this is, remember when we were doing this? These are the ones. These are the 10s. So you borrow a 10 here. Once you borrow that 10, you got 3 10s over here. If you get 1 10 out, so you get 2 10s left. So you borrow a 10 here. So this 10 you got here, this 10 plus 5 is 15. So now you no longer get 5 here. So 10 plus 5 is 15. So this is 6 out of 15 is 9. And 2 out of 2 is 0. Okay? So now, you don't, as you get your remainder here, and this is here we get the 35 is the dividend. The 26 is the divisor. The 1 you got here, that's the answer. This is quotient. And the 9 you have over here is the remainder. Okay, how do you represent the mixed number for this one? Okay, I get a way to do that, but I don't want to confuse you. So your answer would be 1 whole. So 36, not 36, this is 35. 35 over 26, that's an improper fraction. We cannot leave it like that, because the denominator is more than the numerator is more than the denominator. So we need to do something with it. This is equal to, the quotient is what you want. That's 1 and 1. And now what you're going to do, you're going to take the remainder you have here. This is 1 and 9 over 26. So 26 is your divisor. This is 9 over 26. So you see that now the numerator is less than the denominator, and now you get the right answer. You have transformed the improper fraction here, the improper fraction, to a mixed number. This we can live with, because 9 is less than 26. So that's how you do this. Okay, so how do you represent the mixed number? As you can see it here, the mixed number is equal to the quotient. You got it here, that's the quotient here. Quotient Okay, this is 1. That's a quotient. And then what is left? Remainder. That's what we get here. That's the 9 over 26 divisor. You see that 26 here? Divisor. Okay, guys, that's how you represent a mixed number. That's mixed number. This is how I represent that. The quotient, which is the 1. The remainder, that's the 9 we have here, over 26, which is the divisor. And if we're trying to replace the q by a number, the q is 1. That's the quotient we have here. The remainder is 9 over here. That's the remainder. It's labeled over here for you. And the divisor is 26 over here. And you get 26 here. That's how you represent a mixed number. Okay, guys. Mixed number. Let's go and do another one. Another one. All right. Let me give you something something that is a little shorter. Convert this improper fraction 11 over 3 to a mixed number. 11 over 3 to a mixed number. Remember what I told you earlier. So when you converting 11 over 3 to a mixed number, what you do the long division. Okay, long division. So what is the long division? So I do it. I just take the 3, put it here, and I put the 11 over here. So I say how many 3 in 111? In 11? How many 3s in 11? So we're going to say we get 3 3s. So 3 3s, because 4 3s is 12. So we get 3 3s. So now you say you take the 3 here, you multiply it by this 3 over here. And this is multiplication. So 3 times 3 is 9. All right. So once you put this one here, you're going to subtract. Remember that. We're going to subtract over here. And this becomes 9 out of 11. You get 2 left. That's the remainder. So once again, the divisor is dividend. Dividend is this one here, is 11. Is 11. And divisor is 3. The quotient is 3 over here. And the remainder is the 2 you have here. Don't forget the format of a mixed number. The format of a mixed number is the quotient, remainder, over divisor. All right, so quotient, remainder, over divisor. So we'll go back here to see the labels here. So 11 over 3, 11 over 3 here, quotient first, that's 3. That's the 3. You see the quotient here? That's 11 over 3, that's 3. And that's how we read that. And the dividend remainder, that's the 2 we have here, remainder, that's the 2 over the divisor, which is 3. So 3 and 2/3. This is your answer for 11 over 3. Okay? Okay? So now before I let you go, I want to give you, let's now convert a mixed number to a mixed number to an improper fraction. I can ask you that. Let's say I'm going to give you the same mixed number, which was 3 and 2/3 and 2/3. This was the mixed number we found earlier, okay, that we converted that with, okay, the 11 over 3. So now let's say now I'm going to say mixed numbers to improper fractions. So the mixed number, guys, to improper fractions, what you do, and we need to convert that to improper fraction. What you do, you multiply. Let me give you the steps here. Mixed number to improper fraction. Okay. Step number 1. Multiply denominator by whole number. This is a whole number. Multiply the denominator here by the whole number. Step 2. Add the numerator to the result. Number 3. And keep the same denominator. Okay. And once you get this one here, you'll be able to convert any mixed number to an improper fraction. Mixed numbers to improper fraction. So now let's go into this one as we said. So first of all, we're going to multiply the denominator by the whole number. So this is the denominator here by the whole number. This is the whole number. So this is multiplication. So 3 times 3 is 9. That is the result. Okay? So what we do to the result is add the numerator to the result. We're not finished yet. We say 3 times 3 is 9. Step 2, we're going to add the numerator. So 9 plus 2 is 11. 9 plus 2 is 11. That's it. And what we do, we keep the same denominator is 3. Guys, you're done. You're done. So you multiply 3 by 3, that is 9. And to the result, you add the numerator and you keep the same denominator. So 11 over 3 is your answer. All right, 11 over 3 is your answer. So let's do a last one for today. The last one for today. So today we've seen adding fractions, like fractions, unlike fractions, and we've seen improper fractions and mixed numbers, converting vice versa, improper to mixed numbers and mixed numbers to improper. So now we're gonna do another one, 7 and 5/6. 7 and 5/6. All right, so we're gonna convert this mixed number to an improper fraction. Remember the rule, okay? What it says, you take the denominator here, which is 6, you multiply by 7. So 6 times 7 is 42. This is multiplication. 6 times 7 is 42 plus 5. So 42 plus 5 is 47. But what you do, the next, you keep the same denominator, which is 6. 47 over 6. All right, and that's it. So 47 over 6 is an improper fraction. And if I give you 47 over 6, and I want you to convert that to a mixed number, you do the long division again. But if I give you 7 and 5/6, to convert that to an improper fraction, which is 47 over 6, so you multiply 7 by 6 plus 5, which is 47 over 6, and 47 over 6 is your answer for the mixed number to that improper fraction, which is 47/6. Guys, comment and tell me what's going on. Another video is coming up, and this is it for now. We'll continue with fractions the next time we meet again. And don't forget to, once again, comment and subscribe. Talk to you soon and see you in the next video.